Everyone, welcome to Chem 1115, Chemistry and Society. This is the Chapter 8 notes mini lecture over the material from Chapter 8. And as always, I want to remind you that you still need to go read the chapter as well as these notes to be prepared for what you will see on the quiz and on the exam. So in Chapter 8, we're talking about energy storage, and here are some questions to get started. What are the types of batteries? How do they work? What are the kinds of cells that we're going to be learning about? How are batteries recycled, hybrid vehicles, all that great stuff. So here is a reflection that you will be doing on your own. We're going to skip over that. All right, let's learn about a redox reaction. Redox is an abbreviation for the word oxidation-reduction. And if you go on to take other chemistry classes, you will be learning about this process in great detail. In this class, Chemistry and Society, we are just going to talk about it as an overall concept. We're not going to get into all of the nitty-gritty details. We will save that for future chemistry classes. But a redox reaction involves the transfer of electrons. That's the key word right there. A redox involves transfer of electrons from one substance to another. And as we've already learned, the flow of electrons is called electricity. So we can capture those electrons and then we can use them to power electronic devices. And so this is the basic premise behind a battery. So as I just said, the electricity is the flow of electrons. And the power of a battery is called the voltage. So how much power your battery has is in reference to its voltage, and we measure voltage in a unit called the volt. How much electricity is in your wire, that is called the current, and we measure that in amperes, amps for short. And then when you add anything to a circuit like a light bulb, this adds resistance. So that means that it slows down the current. And so resistance is measured in ohms. I'm going to tell you right now, you're going to need to know those definitions: voltage, current, and voltage, current, and resistance. And you're going to need to know the units: volt, amp, and ohm. You'll be seeing those on the chapter quiz and on the unit exam. And so this little picture kind of gives a good schematic for it. A volt is how hard the electricity can get pushed. But then if there is resistance, like a light bulb or whatever you put in your circuit, that slows down the current. So I think this is a good schematic to kind of put it all into a picture form. And so a battery is a system for converting chemical energy into electrical energy. That's our definition for battery. And as you are well aware, batteries are found everywhere, and they have letter notations on them, right? Size AAA, size AA, this is size C, this is size D. And we chemists call batteries galvanic cells. Okay, so if you ever are asked, what does a chemist call a battery? The answer would be a galvanic cell. And then, like the battery in your car, when you have several galvanic cells wired together, that's what we're really talking about. These are batteries as well. Oops. So here's something for you to read over on your own. You'll be seeing questions on your homework about common galvanic cells. And so here are some names. This is their maximum voltage, whether or not they're rechargeable, and then some of their uses. So make reference to that for your homework and in preparation for your quiz and your test. And so this is something really important that you need to understand. The voltage of a battery is determined by its chemical composition, not the size of the battery, okay? That's really important. So alkaline batteries go from AAA to D. They all produce the same voltage. Wow. A lot of people think that that's not true, right? A lot of people don't understand that concept, because if they're all alkaline, they all have the same chemical composition. So what's different between a AAA versus a D? Well, it's because that one can last longer. One can sustain a flow of electrons longer. So that's the main difference, okay? It's not the voltage. As long as they have the same chemical composition, they're all going to produce the same voltage. It's just going to be how long those batteries last. So think about that the next time you change your batteries in your favorite remote control. All right, there are two types of batteries. There are primary batteries, and they are not rechargeable. So a battery that you use once and then it's spent, that's called a primary battery. And a secondary battery is a battery that is rechargeable. That means a battery like what's in your phone or in your laptop, right? Those are ones that you don't just use once, they are rechargeable. So in a primary battery, the redox reaction goes one direction. Once it's all used, that's the end. Whereas in a secondary battery, you have to add electricity to do this, but the redox reaction goes both directions. All right, so here are some examples for alkaline batteries. Now, I'm not going to make you memorize the anode and cathode reactions. This is just kind of for your knowledge, since you've probably never taken apart a battery. And by the way, I don't recommend doing that. Here are some nickel cadmium batteries. They are secondary batteries. Again, I'm not going to make you memorize the reactions, but just so that you can get an idea for what the inside of the batteries look like. This is a lithium-ion battery. Again, not making you memorize the reaction, just want you to get an idea of what it looks like on the inside. And then here's a lead acid storage battery. This is like what's in your car. Again, not making you memorize the reaction, just want you to get an idea for what the inside of one looks like. So if you've ever seen videos on the internet about phones bursting into flames, what would cause a battery to ignite? Well, the reason is that a lot of those elements that are in there, lithium, sodium, really react with oxygen, nitrogen, and water. And so you've got to be really careful about making the battery, because you want to make sure that there's no exposure to air, there's no exposure to water, can't leak in. And so if that separator gets broken, it causes the battery to short circuit. In other words, it causes it to produce a lot of heat. And then also the circuitry in preventing overcharging might go crazy, and then that would cause overheating as well. So here's a little video you can watch on that. Okay, so here's something for you to think about on your own. Read over this on your own. What can you do to keep the metals used in batteries from being lost to landfill? So this is something that you can think about on your own. All right, there is a short video that I put on the YouTube channel and also in Canvas on fuel cells. I have a little fuel cell. It's a very small one, but it's a demonstration of a fuel cell. So you need to go check out that video. I think it's about 40 seconds long. It's very short. But it's a type of cell that converts chemical energy into electricity without burning any fuel. And so you need a fuel and an oxidizer at all times. And sometimes you hear about fuel cells being used in cars. So that's one of the main applications that people are talking about with fuel cells right now. Okay, here's another thing for you to think about on your own. Could metals become extinct? That's kind of something most students don't ever think about. But in 2015, the ACS made this periodic table of endangered elements. Endangered means in threat of becoming extinct, you know, just like an endangered animal. And that has real ramifications for us. So you think about these things on your own. And then if you've ever noticed the Statue of Liberty is made out of copper, but copper is a brown color. So why is the Statue of Liberty green? Well, it's because of redox that's occurring in nature. So oxidation reduction is occurring and it has occurred for a long time on the Statue of Liberty, taking that copper into a copper oxide and changing its color from the brown color that it initially was to the green color that you see today. You'll also see this on any other copper surfaces. You know, if you have a statue outside in your garden, or if you look at copper plated surfaces, they'll turn green, and that's due to redox in nature. So that's where we're going to stop for today. And as always, if you have any questions, please feel free to contact me, and I hope you have a great day.